I recently graduated from University College London, Butler School of Architecture, and my thesis report is being focusing on visualizing material and approach to visualizing functional graded materials. So the main question is how to approach the visualizing the functional graded material. And before how we see material is usually we can only see through the outside or being cutting through that material in a more physical way. And the main focus inside this particular image is using Rhino, and I stack all the MRI brain MRI image together, and then I exploring the internal structure of this brain. And the issue that I found is hard to describe the material inside the brain tissue. Also, the Rhino has some boundary representation issue, so the is very hard to find a way to correct the describe the material and the structure inside the brain. And I also use a stack of other MRI image, and then I cut it through the liver side of the body, and it's also have a similar issue with this kind of image stacking. And so I have do some research on voxel printing, and I also trying on the other program like Monolith developed by Autodesk, but it now has been suspended, so there are no further development of the Monolith program. And then I try to using Houdini, voxel using the voxel node to create a similar using a same stack of RAM MRI image, but with different voxel density. And as you can see on this image, the based on the MRI image, it is a very low resolution image. So the brain of the interior of this brain has been separated by the voxel. Even the voxel density, it already decreased to 0.001. And further on, I used a more high quality MRI brain unit, and I comparing into a 100 micron unit MRI brain image inside Houdini. And it has more clearly that there are some structure growing out from this voxel-based software. And then I downloaded some some MRI scan data from the um, from the website of the more scientific website, and they have a lot of free information and data that's stored on that website, and I try to use that data to visualizing the brain vessel MRI model inside using the similar procedure. And I also try to cut the brain skull of the MRI model and seeing the structure inside. And based on that based on that detail quality of the model, and you can see on the right image, I try to visualizing them and render it using the same material, and they are all almost obvious to see that the density have separated in a specific area. And then moving on, I try to focusing on the functional graded material, and functional graded material can often found in the human body, especially inside the bone structure and the tissue between the bone and the bone have the functional graded material. And then I have a CT scan model of the foot and ankle. So I try to visualizing the material in between the ankle and the bone structure. And in between the ankle of this structure, you can see that there are some transparent area. If the voxel density has decreased it more, and you will have a more and higher quality of the of that material coming out. And this is the cross section of the human bone, showing the healthy human bone and the unhealthy human bone. So I try to have a healthy testing on the healthy bone and an unhealthy bone structure based on the different density of the voxel size. And on on that model, as you can see, if the model have a cross-section slice, in the healthy bone, there are more continuous structure in those slices, but in the unhealthy bone, the cross-section would be appearing more separate, and the structure is is discontinuous, and the transparent thin area on the right hand side has more transparent in area. And then I try to do porosity distribution. I try to creating a similar with the bone structure, but I try to use the topology optimization to optimize the structure that's growing inside of this block. And inside this block, the stress is based on the top side, and the supporting side is on the bottom. So the the optimizing area has grown into more like a Y shape, and then I tried to cutting through the core area of that shape, and there are some density variation inside that shape. And then this one is using the flow procedural modeling to create this kind of functional graded material. And on the upper side of this model, it can shows that there are some transparent area and are supporting by a different variation of this functional graded material. So I test on the different voxel density and density structure distribution, and I try to create a similar bone-like structure, and the structure overlapping each other. And then on the right-hand side, the cross-section of the slice can see the structure is more heavier on the bottom and grow eventually on the top is almost empty. Okay, thank you very much.